So, so if you are sad enough, you are bored enough, you can watch it again later and see how great you looked on the screen. Mathari Mix going, yeah, we look great. And that will be good. So I'm going to start by sharing my screen in just a moment. I just need to check the chat. That's okay. Okay, students, ladies and gentlemen, teachers, everybody welcome. Today we are doing moles number 3. Now, so far we have met the 3 triangles, which I hope you know. We have done quite a lot of moles calculations. Today is the last bit, which is about empirical formulas, molecular formulas, and using Avogadro's number. Ah, but first, I must mention something. And the something I must mention includes these people. Ah, who are these people? What have they done? Well, if I was going to have a picture of students on the and teachers on this, they must have done something pretty good. Well, they did do something pretty good. They won the chemistry contest gold medal for the mixed senior team. And therefore, these particular students and that particular teacher should be very, very proud. So I would like us all to welcome Mr. Wafula and Mathari Mixed, who actually won the whole competition. I think that's amazing. I really do. And it says so much for the teacher and so much for the students that I'm going to stop sharing and I'm just going to ask them to show what they won. Show us, guys. Mathari Mix. Hang on, let me just wait a minute. I'm just going to see if I can spotlight for everybody. Ladies and gentlemen, look at that for a medal, huh? I mean, a cup. Look at that. They are finally famous. And some of them are shocked. But look at that for a trophy, huh, guys? You're going to have a big cabinet put up in the school. Look at that, Kenya High School gold. It's just superb. I'm really, really pleased for you. And congratulations to Mr. Wafula and his students who are not even trusting themselves to speak anymore. So well done. You have been spotlighted by everybody. And I, for one, applaud you. I think it's really, really good. Now, what they do, every one of you can do. Every one of you can do that sort of thing. And I mean it. All you have to do is believe and be willing to do the work. So we're going to do some work today. But what I want you to do is to think very carefully about doing enough work to be able to make yourself the gold medal person, to make sure that when we get to the final exams, that you are going to be up there as a winner. And to do that, you have to do quite a lot of work. You have to do quite a lot of work, which is a bit of a drag. Sometimes you think, nah. And today you've done a whole day of school, and now you've got to do some more. So congratulations to Mathari Mix, and let's go on with today's lesson. Thank you very much, Mathari Mix, for being shocked. Okay, so here they are. And well done, team. That's great. Okay, so today we are going to study and practice. Incidentally, the word practice can be spelt with an S or a C at the end, towards the end. But practice with a C is the noun, and practice with an S is the verb. So if I want to do some practice, that would be C. If I am going to practice, that's with an S, but that's just a little bit of an aside English. So here we go. Right. I'm just going to move people out of the way a little bit on my screen. Okay. So today we are going to study and have a go at some empirical and molecular formulas. We're going to use Avogadro's number, which is the number of particles in a mole. And we're going to look at a couple of examination questions so we can see how it is that we gain all the marks that we need. So we're going to start with empirical and molecular formulas. We're going to do a little on Avogadro's, very simple, because it is simple. And then we're going to look at examination questions. Okay, so I hope you are sitting comfortably. You have something to write with and some paper or a book or something. Let's go for it. So, firstly, you need to know that empirical formula is the simplest ratio of the atoms in a chemical, in a molecule. The simplest ratio. Now, there is a machine called a mass spectrometer, and a mass spectrometer breaks down molecules into all the atoms, and it calculates the number of carbons and hydrogens and oxygens, nitrogens, sulfurs, whatever, as a simple ratio. So the atom which has the fewest number in it will be 1. So let's say we have we have a compound which has 6 carbons, 12 hydrogens, and 6 oxygens, which is like glucose, then the 6 becomes 1. Here it is, glucose, C6H12O6. When we simplify that, we can divide through by 6, and it becomes 1 to 2 to 1. What the mass spectrometer does not do is to tell us that it is C6H12O6. It tells us that it is CH2O in that ratio, but it also tells us that the whole molecule weighs 180. So we can then work out what the proper molecular formula is. But the mass spectrometer cannot tell us that. So if it's the simplest ratio, let's see if we can do a question on this. Just have a look at these. What is the empirical formula going to be for these chemicals here? The first one is hydrogen peroxide, H2O2, copper sulfate, CuSO4. C2H4O2 could be quite a lot of different chemicals. For instance, it could be ethanoic acid. Excuse me, but it could be ethene diol, all sorts of things. Then we have C6H6, which is benzene, and H2SO4, which I think you know is sulfuric 6 acid. So just work out yourselves what is the empirical formula for each one of those. For those of you who are not very happy about this, I'll just show you with the first one. So in the first one, we've got 2 hydrogens and 2 oxygens. So what I can do is to divide the whole thing by 2, and therefore its simplest ratio is H1O1. We don't need the ones, so it just becomes HO. So that's how we work out the empirical formula. We are looking for the lowest common multiples. In other words, we are looking what we can divide all of them by to simplify. Just spend a moment, see if you can work out, it could be in your head, see if you can work out what the empirical formula is for each one of these. Quite a lot of people already got the answer. I'll just check in just a moment. So, show me again, Dandora, please. Show me again. CuSO4, C2H2O. is that C2H2O? CO6CH, yes, and HSO2. No, it's not HSO2. They're all right except the second one down and the last one. Have another look. Anybody else want to have a go? Oops. Anybody else want to have a go? Something is going wrong with my screen at the moment. Why is that happening? Ah, there we are. Now I can see everybody. Okay, does anybody else want to try telling me what the answers are? Mathari Mixed, I think you can do this. Mathari Mixed can do everything. Kibiro, Wamuini, have a go. Anybody? Glory, St. Michael's? What, you want to show me your answers? St. Mary's, anybody want to show me the answers? Wamuini, let me have courage, Wamuini. Dandora girls, I've nearly got it all right. Nearly. HO, little bit further away, please, Wamuini. CuSO4, very bright. CH2O, really good. Very, very good. Who's that? Wamuini, who is the star there? He's gone all shy. Okay, that's all right. Oh, no, hang on. I can't see your name. It's too bright there. I can't see your name. Anyway, so ladies and gentlemen, so that will be therefore, that will be HO. We cannot simplify CuSO4 because two of them are one. If you go through these, if there is anything which is one already, you can't change it. So that must be CuSO4. Whereas this one here, we've got 2 and 2 times 2 and 2. Oops, what's happening? Oh, come on. Sorry. Coming back. So good. So this one here will, this one here, oh, come on. Why are you being silly? Sorry, my pen is being silly. It is trying to control my screen. So this one here will come out as C1H2O1, but we don't need the ones. This one here would just be whole divided by 6, so it'll be just CH. And this one here, because we've got the 1 on the sulfur, we can't change it. It has to be H2SO4. So anytime you see a 1, you cannot change any of the others, okay? So whatever I give you, let's say I have C2H6O, because I've got effectively a 1 here, I cannot change the whole thing. Whereas if it was C2H6O2, then I can change it and divide through by 2. If that divide by 2, that will be C1H3O1. Okay? All right, so let's move on. Now, I want to introduce you to Dr. Empirical. Dr. Empirical is how I teach my students to do the empirical formula in the questions that we get set in my country. So here she is, and she says, I am Dr. Empirical. Now, it's not actually necessary to remember her name. It's the IMDR, because IMDR stands for information, moles, divide, ratio. So here's an example. It's 70% iron and 30% oxygen by mass. And iron has a RAM of 56, and oxygen has one of 16. So what do we do? Well, we've got the information. There's the information. 70% iron, 30% oxygen. I need to work out moles. Well, from my triangle, I know that if I've got masses, moles is grams over rams. Okay, grams over rams. And therefore I can do my moles, and then I divide through to find the ratio. So the information is there. Iron 70, oxygen 30. The moles will be 70 divided by 56 and 30 divided by 16. So that gives us the answers of 1.25 and 1.875. Then I divide through those two numbers, or as many as I have got, by the smallest number. So 1.25 divided by 1.25, 1.875 divided by 1.25. So this becomes 1, iron becomes 1, and the oxygen becomes 1.5. Now I can't have 1.5 oxygen atoms. So what I have to do is to look at 1 to 1.5 and double both of them, and therefore the ratio becomes 2 to 3, and it's Fe2O3. Okay, so let's just go back through that, make sure everybody's got it. So we use information, moles, divide, ratio. Okay, so we write down all the information. Then we work out the moles, which is the grams over the rams. Okay, grams over ram, 70. Because if it's a percentage, sometimes they will give you a mass and sometimes a percent. But the percent, you just have to think, okay, if I had 100 grams of this, 70 grams of it would be iron and 30 grams would be oxygen. So I've got the moles there. Then I divide through by the smallest. Well done. Well done, St. Mary's. Very good. You're obviously going to find this very easy. Well done. And then I get the ratio. So it's 2 irons, 3 oxygens, and so it's Fe2O3. Now, for some of you, this is so easy, I think it's time that you had some to do. I'm going to show you one more laid out in a slightly different way, okay? So what's the empirical formula of a chemical that is 37.2% carbon, 7.75% hydrogen, 55.0% chlorine? Well, if I work it out, and some people prefer it vertical and some people prefer it horizontal. Here it is horizontal. So I'm going to put the chemicals. Then, if you remember, information, then moles, then divide, which gives me the ratio. So 37.2, 7.75, and 55 is the information. The moles, 37.2 divided by 12, 7.75 divided by 1, 55 divided by 35.5, and we get these numbers which are a bit strange: 3.1, 7.75, 1.55. We then find the smallest of those numbers, the 1.55. We divide all of them by 1.55. So 1.55 over 1.55 is 1. 3.1 divided by 1.55 is 2. 7.75 divided by 1.55 is 5, and therefore it is 2 carbons, 5 hydrogens, 1 chlorine, C2H5Cl. Okay, I'll come back to that slide, but I just want to ask, is that okay for everybody? Is everybody okay on that? Is this all quite easy? Oh, not Wamawini, not quite so happy. St. Mary's, is that okay? St. Mary's? Hello, St. Mary's. Cool, excellent. Kabiro, is that okay? Kabiro? Kabiro? Not so okay. St. Michael's, is this okay or not okay? Sort of okay. Oh, okay. Dandora, I think it's okay. Glory, I'm sure, Mathari, it's okay. Let's go back over it again. So we're going to make sure that everybody can do this. Here we are. Okay. So I'm going to draw this one out. I'm just going to escape. I'm just going to draw this one out so you can see how it works. Hang on. Let me just show you how this works. Okay. So we're gonna have a look at this one. Okay, we're going to have a look at this one here, which is 70% iron and 30% oxygen. And I'm going to show you how I would do it myself. Okay, so here we go. So I would normally draw it out like this. Let me just get a drawing pencil. This is only for those people who are not quite familiar with this. Okay, so I would draw some lines across my piece of paper like this. And I would say, okay, I'm going to have iron and I've got oxygen, and I'm going to go I, M, D, R. I'm doctored, remember? So my information was I've got 70% iron and 30% oxygen. Okay. Then I'm going to work out my moles. Now, my moles from the triangle, the very first kind of triangle there is moles at the bottom. Whoops, what on earth is happening there? Ram down here and grams up there. So if I want moles, it's moles equals grams over RAM. So that is 70 over 56 and 30 over 16. Okay, so far, I hope. Now, if you look at if we worked it out, the numbers come out as 1.25 and 1.875. So this is here, this is 1.25, and this is 1.875. And in division, we divide each one of these numbers by the smallest one, right? So that one is 1.25. This one is 1.875. So this is 1.25 divided by 1.25. That's obviously 1. 1.875 divided by 1.25 is 1.5. Now we can't have 1.5. So we double both of them, and this ratio becomes 2 and 3. And therefore the chemical is Fe2O3. Okay, let's just look at all of that again. I draw some lines out. I put down the information which I've got. So I know I've got iron and oxygen. And I know I'm going to do I, M, D, R. Now, the information I was given in the question is it is 70% iron, 30% oxygen. Okay. Then I want to work out moles. Now, moles is grams from that triangle is grams over the RAM. Okay, moles in the triangle we have RAM at the bottom. Sorry about the funny little lines, my apologies. RAM at the bottom and grams at the top. So we cover the moles, and that tells me that moles equals grams over ram. So that's 70 divided by 56, which is 1.25, 30 divided by 16, which is 1.825. So these are the numbers. So then I divide by the smallest number, or if there are a lot of numbers, I still find the smallest and divide them all by that smallest number. So 1.25 divided by 1.25, that's obviously 1. 1.875 divided by 1.25 is 1.5. I can't have a half, and so I double both of them to get to a whole number. And therefore it is Fe2O3. Okay, I hope that's a bit more sensible. Let's just look at the next one. Let's just go for this next one. So in this one, it had 3 chemicals, okay? 37.2 of carbon, 7.75 of hydrogen, 55 of chlorine. Here's the table as I've done it just now. Carbon, hydrogen, chlorine. That L should be lowercase, but sorry. There's the information, 37.2, 7.75, 55. Divide those by the rams. 37.2 divided by 12, 7.75 divided by 1, that's the ram of hydrogen. Chlorine is 35.5, so divide that by that. There are the 3 numbers, 3.1, 7.75, and 1.55. 1.55 is the smallest. Divide 3.1 and 7.75 and 1.55 all by 1.55. 2, 5, 1. So the answer is C2H5Cl. C2H5Cl. I hope that made a bit more sense. Is that a bit better? Are we okay now? St. Michael, good. Thank you, Wawini. Thank you, St. Mary's. That's great. Kabiro, are we okay now? Are we okay now? Kabiro? Thank you. Excellent. Brilliant, St. Michael. Thank you very much. There's no point in asking Dandora girls because they never understand anything. They're absolutely hopeless at chemistry. That's not actually true. But today they are definitely second to Mathari Mix, who are the gold medal winners. Okay, so, okay, everybody, I hope that's okay. So here we go. Onwards. So let's have some that you can try yourself. If you're feeling quite, you're really beginning this, try this first one. It doesn't tell you how much percentage is oxygen, so you have to work that out. Remember that it's all going to add up to 100. The second one is a bit more difficult because you have to work out the mass of oxygen, okay? Because it said it's just copper and oxygen. And the third one is even more difficult. So have a go. I'm going to give you, let's say, 6 or 7 minutes to have a go at one of those and see how you get on. Okay, just have a go at any one that you want, either 1 or 2 or 3. It doesn't matter. I'm going to help a little bit as we go along. I'm going to show you a little bit of how to do it. Okay, in the first one, I know that 100 is the total. So I have to add together the percentages which I have at the moment, which is 52.2 and 13, and take them away from the 100, and that will give the percentage of oxygen. In the second one, the copper oxide weighs 1.59. When the oxygen has been taken away, the copper is 1.27 grams. Okay, so that should allow you to work out how many grams of oxygen I have. In the last one, we've got three chemicals. So it's carbon at 60% and hydrogen at 4.4% and oxygen at 35.56%. And that's my information IMDR. Okay, so that's how you approach each one of those. Have a go at whichever one you want to. Ooh, Mathari mixed. You are on fire. And St. Mary's, you guys are just too fast. Too fast. Well done. Who is that at Mathari, please? And St. Mary's. Please put your name on the work. That was Mathari mixed and St. Mary's, both very fast. Put your name on your piece of paper and show me it, please. I would like to call out your name. It's very, very fast. Well done, Joseph, at Mathari Mix. Well done. I hope you were part of the team. Dandora girls. It's very light. You've got lots of sunshine on there. And across a bit, please. E40. What have we got there? Are you doing the first one? Oh, see you. No, it's not. Hang on. Show me again, please, Dandora. Oh, it's CUO. My apologies. Okay, good. And your name? Oh, you're covering your name. Nanjo? Brilliant. Oh, two people, Shanice and Celine. That's like cheating. Two people. That's wrong. That's outrageous. So have a go at each one. Everybody have a go. Kabiro, have you had a go? See if you can do one. Mathari Mixed, Dandora, and St. Mary's have all got right answers so far, which is great. St. Michael, have a go. Show me your answers, please, Wamuini. St. Michael, yeah, show me. One of them or both. Show me one first, and then show me the other one. Show me anyone. Closer, please. Little bit closer. C2H60. Yes, good, excellent. What's your name, please? Very, very good. You guys are very good. I'm very pleased. Well done. You're allowed to write your name on it so that everybody can hear that, hey, Mary is fantastic, or whoever. St. Mary's CUO. Up a little bit, please. Alvin, brilliant. Lamech, brilliant. Really good. Very, very good. You students are really good. I'm really pleased. Okay, so we're going to move on. I know some people haven't finished, but you will be able to have another go later. So here we are. We're now going to move on. So the first one The amount, here's IMDR. I'm writing it in this case this way. It doesn't matter whether it's vertically or horizontally, doesn't make any difference. Carbon, we work out the oxygen and it comes out as C2H6O. IMDR, just carry it through. Every student who put the answer up on the showed me their answer was right, which is great. Well done. The second one comes out as CuO. Quite simple, but it's a very common question that they give like that, where they ask you to work out the amount of the oxygen or something like that. In this case, 0.32 of the oxygen, and therefore now you can do it. In the last one, it comes out, and it's quite a complicated one, but it comes out as, and this is very, very important, you must not approximate. Okay? You must not approximate. Number 3, it looks like 2 to 2 to 1 or 4 to 4 to 2 or something like that. But actually the numbers are 2.25, 2 and 1. Not, these two are not the same. Because they're not the same, you have to divide through. And that's the smallest number there is 2.225. 2.225. So there is only one oxygen, and there are 2 of the hydrogens, and there are 2 1/4 of the carbons. Look at this one carefully. The smallest number is 2.25, 225. Okay, that's important here. The 35.56 divided by 16 is 2.2225. So that is the smallest number. Do not approximate. And therefore, that and this, the 5 and the 4.44 need to be divided by 2.2225. The answers come out as 1 to 2 to 2 1/4. To get 2.25 up to a whole number, we have to multiply it out. If we multiply by 4, we get 9. 2 by 4 is 8. And 1 by 4 is 4. So it's C9H8O4. Then it said in the question, here's the question, here at the bottom, it tells you its RMM is 180. When you work it out, if you look at this chemical here, C9H8O4, and you add it all up, so 9 12s, 8 1s, 4 16, it is 180. So that is the molecular formula. It's the formula of one molecule. So the molecular formula, you have to work out the empirical formula and then look at its, what we call, excuse me, its apparent RMM. So in other words, if I think something is HO, I work out HO, and that's just 1 and 16, which is 17. But I am told that the RMM is 34. Well, that's twice as much. So how many HOs do I need? 2. So it's H2O2. It's not 2HO because H2O2 is actually built like this. That is H2O2. But 2HO would mean one HO and a different HO. So it's not the same. So H2O2 does not mean the same as 2HO. That's very important. So if I find that my RMM is 34, that the empirical formula has what looks like an RMM of 17, then I need 2 of them, and I have to double the whole empirical formula. Okay? All right. So here are some where you have to work out the molecular formula. You're given the empirical formula, and you have to work out the molecular formula. So just have a go at that. Could I go through the third question, Dandora? Was that Dandora? I could go through the third question at the end again. I could go through the third question at the end again. I will show you it. Okay. So just have a go at this, please, everybody. Just have a go at this. There are some empirical formulas and some, and some RMMs. So you can have a go and see if you can work out the molecular formulas. There they are. CH2O, but its RMM is actually 120. Yeah, show me, Mathari. That's correct. Well done. Mathari makes you really have worked very well. I'm very impressed. Lamech, I've come across you before. That is correct. I think from what I saw, and Joseph, that's very good. I think C2H4Cl2. I think that's correct. I will have a look in just a moment. So all you do is to add up what we've got and find the empirical formula. So if I look at this here, this would weigh 1 carbon is 12, and one hydrogen is 1, so it's 2, and 16, so that would be 30. Now, because it's 120, very good. So it's 120 divided by 30 is 4. So as somebody at St. Mary's has just said, I need not CH2O, but C4H8. Well done, St. Mary's. O4. Well done, St. Mary's. Exactly right. Well done. Good. So have a go at the other ones. FES, is it FES or Fe2S2 or Fe3S3? And CH2Cl, is it CH2Cl or is it more? I'll give you the answers in just a moment. Give you all the answers in just a moment. Students are working really, really hard today. I hope your teachers are pleased with you. It's very good. At the end of a day, to work like this is very impressive. Well done. Very, very good. Thank you for being such excellent students. Show me Wamwini. It's very bright. Your camera is a bit bright. Hang on. Let me see if I can just pin. Hang on. Patricia, down a little bit, please. Down a little bit. No, just down a little bit. I couldn't see it. FES is correct. C2H4Cl2. FES. Well done, Dandora. Well done, St. Mary's. Well done, guys. You are very good. Well done today. Joseph, C2H4Cl2. Well done. C2H6O. Good. Well done. Very good, Mathari. Many, many students being very clever today. I think maybe I should just sack myself. I'm gonna sack myself. You guys don't need me. I'm just gonna go. Okay, let's have a look at the answers because we haven't quite finished. So let's just have a look. Let's see how it goes. Okay, so if we've got CH2O and an RMM of 120, there, first one, then it comes out as 4 times as much because that is only 30. FeS does add up to 88, so it is FeS. CH2Cl works out as half of 99, so we need to double the whole thing, C2H4Cl2. Well done. Okay, here are some examination questions. These are proper examination questions actually taken from the KCSE examinations. This one is worth 4 marks. Okay, that is a huge number of marks. The second one here, the same sort of thing. The first one is easier. The second one is more difficult. Okay, I would do the first one first. I would do question 1 first. I would do question 1 first. Sorry, show me again, please, Mathari. Thank you, Phyllis. Phyllis, you are a star. Phyllis, that is really excellent. Well done. Well done, Phyllis. And up a little bit, C4H822. Well done, St. Mary's. Very, very good. Very, very good. Well done. Excellent. So the gold medal went to Phyllis at Mathari Mixed. The silver medal went to somebody at St. Mary's, but I didn't know your name. So what's your name? That would be nice to know. Doesn't matter, though. You know you got silver. Everybody have a go. When you have a go at the second one, it's a bit more complicated. You just have to remember that a hydrocarbon, let's say it's CH4, when it burns, it will give carbon dioxide and 2 waters in this case. Okay, if I balance it there. Now, the point is that I had 1 carbon and 4 hydrogens, and it gives 1 carbon and 2 waters. So however many waters, we want the ratio of carbons to hydrogens are carbons here and hydrogens here. And that's 1 carbon and 2 waters, which is 4 H's. It's 1 carbon and a ratio of 1 carbon to 4 hydrogens, okay? So you've got to be very careful. The number of carbon dioxides gives you the number of carbons, but the number of waters gives you half as many as there are hydrogens. So if you want to have a go at that, that's absolutely fine. Anybody going to have a go at question 2? Question 1 has been done really, really well by a number of students. Really, really good. Anybody doing question 2? Silver Spring? Okay, let's just have a look at this. Let's make sure that we're okay on this. So the first one is just like all the other ones. All we do is to construct the long line like this. And I know that I've got carbon and hydrogen and oxygen. And I know in my I, M, D, R that I have 54.55 of this, 909 of this, 36.36 of this. So I then work out my moles, I divide by my smallest, I get my ratio. Now my ratio actually comes out as quite small numbers. When I add them up, I find they come to half as much as I need. I'm not going to go through all of it now in case people want to have a go later. in this second one here, something rather different happens. So I've got a carbon X to hydrogen Y, and it's going to burn to give X CO2s and Y over 2 H2Os, because each H2O, so I need twice as many H's to give the H2O. Now, to work out the CO2, I have 2.88 cubic decimeters. Well, I know that for gases, I have to divide that by 24 to give me the moles, okay? For the water, I get 2.16 grams of it. I have to divide that by 18, which is the RMM of water. And I will leave it like that because I want you to have a go. If you feel like you want to have a go at this later, I will send the presentation to your teachers. You can have a go. But these are huge questions. Everybody who showed me the answer to number 1 got it right. That is huge. To be able to get 4 marks on a question like that one is really, really excellent. Okay, we're moving on. We're not going to do this, but your teachers can do it, because I have one other thing I want to do in the last 10 minutes. In this one here, it talks about magnesium sulfate having a certain number of waters of crystallization. Its formula is, as it shows on the second one here. Let me just ring it so you can see it. The formula here is MgSO4 NH2O. So N is a certain whole number waters. So I'll give you an example. Copper sulfate, when it is blue, it is always 5 H2Os. Okay, so the integer for copper is 5. Na2CO3, CO3 is 10 waters. Okay, so we're trying to find out what that number is there. Now, it starts with 4.92 grams of the original chemical. And what is going to happen is that the MgSO4 NH2O is going to be separated into MgSO4 anhydrous, in other words, with no water, and NH2Os. So you have to try and work out this. Now, it tells you that it starts with this chemical here, starts at 4.92 grams. And afterwards, this chemical here is 2.4. So the water must be 4.92 minus 2.4. And then you should be able to work out the moles of this, the moles of that, and find the ratio. Okay, that's how you do it. Okay, so I'm going to move this on now, just because with one other thing we want to do. I think you'll. So here we are. This is using Avogadro's number. Just occasionally, they have asked you to use Avogadro's number. Avogadro's number is 6.023 times 10 to the 23. So what they want you to do is to work out how many individual atoms there are of Na in 4 grams of NaOH. So what I want to do is I want to work out the moles of NaOH and therefore the moles of Na. So I find the moles of NaOH, and that is going to give me the moles of Na, and then I multiply that by 6.023 times 10 to the 23. Now that's actually really simple, because NaOH weighs 23 and 16 and 1, which is 40. So the moles of NaOH is grams over RMM, which is 4 over 40, which is obviously 0.1. Because it's 0.1 moles of sodium hydroxide, and there is only one Na in each NaOH, that equals 0.1 moles of Na. Well, then we go, well, how many is that? Well, that's 0.1 times 6.023 times 10 to the 23, which is 6.023 times 10 to the 22. That's the number of individual NAs in 4 grams of NaOH. Okay? I see. Sorry, has it gone down to the bottom? My apologies, St. Michael's. St. Michael, I'm very sorry I didn't see your comment. But we will go through anything. I think you would be able to see it on the recording. Okay, so have a go at this one here, the second one. Just remember that there are 3 O's in each CaCO3. So work out the moles of CaCO3, and I'll tell you that the RAMs are calcium. Whoops, I think you'll be able to do this yourself. Hang on. All you have to do is remember. Ah, come on. My apologies. So calcium weighs 40, carbon weighs 12, and each oxygen weighs 16. Okay, so you can now work out the RMM of CaCO3. Divide that by it, will give you the moles of CaCO3, and then you have 3 times as much of oxygen. Have a go. We've only got about 2 minutes left. So from that, the RMM of CaCO3 is 100. So the moles of CaCO3 is its mass, 0.0055 grams, over 100. That's a start. So how many moles of O will there be? Well, there are 3 O's for each CaCO3. Well, that number there would be 5.5 times 10 to the minus 5. So how many moles of oxygen would that be? Well, because CaCO3 gives 3 oxygens, 3 times oxygen, Therefore, 5.5 times 10 to the minus 5 would give 3 times 5.5 times 10 to the minus 5. And then you multiply that number by 6.023 times 10 to the 23. Okay. That, ladies and gentlemen, is really the end of the lesson. So I'll give you the answer. 0.0055 grams of calcium carbonate is 0.000055 or 56 of calcium carbonate. There are 3 of those, so it's 0.0001665. And you multiply that by the 6 times 10 to the 23, which gives us 1 times 10 to the 20. In the last example, how many atoms of hydrogen in 10 grams of sucrose? Sucrose is C12H22O11, which has an RMM of 342. Well, if I've got 10 grams of sucrose, then it would be 10 over 342 for the sucrose times 22, because there are 22 hydrogens in there. That times 6 times 10 to the 20, 6 times 10 to the 23 gives me 3.874 times 10 to the 23. That is, ladies and gentlemen, the end of this lesson. It is quite a big and hard lesson in some ways, but you have done really, really well. My congratulations once again to our heroes of last week, to Mathari Mixed and Master Wafua. But today we are going to say goodbye. This has been recorded. If you want to look at it again, that's fine. The presentation itself with all the working will be sent to your teachers. I'm going to stop the recording now, but one team wanted to look at question 3 from one of the other questions, from one of the earlier ones. So I will stay here and do that in just the RMF, relative molecular formula. I'll go through with you next time, St. Michael. But I'm going to just go through that question 3 for anybody who wanted to go through that. But otherwise, have I stopped recording? I think so.